Hello, welcome to Maths with EJD. In this video, I'll start talking about probability, which I know is a very important aspect of mathematics. Of course, the first question you want to ask is, what is probability? What is probability? Probability. Okay. So, first of all, talking about the definition of probability, probability is a branch of mathematics that deals with the likelihood, with the likelihood or chance, likelihood or chance of different outcomes, of different outcomes. So probability simply talks about the likelihood or the possibility or the chance that a particular outcome is going to happen. Okay, so it quantifies uncertainty. So probability quantifies uncertainty, providing a way to measure how likely an event is to occur using values between zero. Zero is the probability of impossible events. So when an event is totally impossible, then the probability is zero. So using values between zero, impossible events, and one, that is for certain events. So when you're sure something is going to happen, then the probability is one. For instance, what is the probability that next month is December? I mean, currently, as you can see on my screen here, for my location, today is Monday, September 9th, 2024, 10:29 p.m. So the probability that tomorrow is Tuesday is one, sure. Nothing can change it. But then the probability that next month is December is zero, because next month is actually October. Okay. So probability is usually between 0 and 1. So whenever you find you're looking for probability and you get a value less than 0 or greater than 1, then you should know something is wrong, because every probability is bound between 0 and 1, as you're going to see more about this later. So that's talking about the definition of probability. How about we talk about the importance? Why is the quantification of chance necessary, or why is it important to quantify uncertainty? So the importance of probability is crucial. It's crucial in various fields, such as statistics, then finance, engineering, medicine, and everyday decision making. So probability is that important. Okay. And then it helps us understand and manage uncertainty. So probability helps us to understand and manage uncertainty, make predictions, predictions and optimize outcomes in uncertain situations. So, I mean, this reminds me of this whole thing about genes and alleles, for instance. Like, what is the probability that a parent with two dominant genes and another parent with two recessive genes, when they have children, they will have, what will be the possible gene combination? So some probability can really come into that. So we can manage uncertainties like that. So let's talk about some real life applications of probability, real life applications. So first, we can see it applied in weather forecasting. Weather forecasting. So meteorologists use probability to predict the likelihood of rain, snow, or other weather conditions based on historical data models. Based on historical data, rather, and models. Okay, so probability is crucial to weather forecasters. Then we have medical decision making. So here, doctors use probabilities. Doctors use probabilities to determine the chances of a patient having a particular disease based on symptoms, tests, and risk factors. Okay, so doctors use probabilities to determine the chances of a patient having a particular disease based on symptoms, tests, and risk factors. So let's talk about insurance. Insurance also requires some probability. So insurance companies calculate premiums based on the probability of events, like accidents, natural disasters, or health issues. All right, so I'll also like to talk about quality control. Quality control. So manufacturers use probability to assess the likelihood of defects in products and improve quality. Okay, I mean, these are just some areas where um where we can apply probability in real life. There are so many other areas. Okay. All right. So let's talk about some basic concepts in probability. Basic basic concepts. So we have something called experiment. Experiment. So experiment is simply a procedure that yields one or more outcomes. So anything you do that is capable of giving you one or more outcomes, that is actually an experiment. A very good example would be rolling a die, rolling a die, or drawing a card from a deck. So when you roll a die, right, you have the possibility of getting a one or two or three or four or five or six and all that. So of course we also get to talk about ideas like fair die, unfair die, and things like that. So rolling a die or drawing a card from a deck. If you draw a card from a deck, you can get a spade, you can get a queen, and things like that. So that is what an experiment is. Any procedure that yields one or more outcomes, that yields one or more outcomes is actually called an experiment. Okay, so let's talk about outcome. Okay, the idea of outcome came up when we talked about experiment, right? So an outcome is simply a possible result of an experiment. So an outcome is a possible result of an experiment. So any outcome, any result you can get from an experiment is an outcome. For instance, just like we talked about rolling a die, right? So if you roll a die, one of the possibilities is getting a 3. So rolling a 3 on a die is an outcome, is an outcome. So the experiment is rolling the die. The outcome is getting a 3, all right? Or any other thing, any other possible thing you can get, like a 1 or 2 or 3 or 4 or 5 or 6 and so on and so forth. So that is what an outcome is. Then that takes us to the idea of event. So we've talked about experiment. Now we've talked about outcome. Let's go now to event. So what is an event? Event is simply a set of one or more outcomes, a set of one or more outcomes from an experiment. So you can say everything is linked with the experiment. So an event is a set of one or more outcomes from an experiment. Again, an example may just be something like something close to what we've seen before. That rolling an odd number, of course, it is one thing to roll a 3. Then if you can also roll an odd number, like, so all the possibilities of 1, 3, and 5. Rolling an odd number or an even number or a perfect square, all of that. Rolling an odd number, which is 1, 3, or 5, is actually an event. An event. So a set of one or more outcomes from an experiment. Of course, rolling a 3 is also still an event, right? But the only thing is that the idea of event is expanded. It doesn't have to be just strictly one outcome. So an outcome is a possible result, just a result of an experiment, but an event is a set of one or more outcomes from an experiment, like rolling an odd number, which is 1, 2, 3, or 5, or rolling the perfect square, which is 1 and 4, or rolling an even number like 2, 4, 6. Those are all events. Now, let's talk about sample space. Sample space. Sample space. So a sample space is the set of all possible outcomes. And this is really important. And under set theory, right, we already got a glimpse of what a sample space can look like. So the set of all possible outcomes of an experiment is a sample space. Okay, for instance, we've been talking about rolling a die, right? For rolling a six-sided die, the sample space is the collection of all possible results. Like you can get a 1, you can get a 2, you can get a 3, you can get a 4, a 5, or a 6. So when you put together every possible thing you can get, that is what you call a sample space. So that is a sample space. Now, let's talk about, so here now, these are some basic concepts relating to probability. We have experiment, we have outcome, we have event, and sample space. So let's move on as we talk about types of probability. Types of probability. So the first type is theoretical probability. Theoretical probability. So here, based on the assumption, that all outcomes are equally likely. This is not always true. That is why it is said to be theoretical. So if you assume, for instance, we just assume that when you roll a die, you always get 1, 2, 3, 4, 5, 6. But what if the die is unfair? Maybe, in a gambling game, for instance, someone tries to, manipulate the die. It can actually not, so you can't be guaranteed having 1, 2, 3, 4, 5, 6 like that. Okay. So based on the assumption that all outcomes are equally likely, we have a theoretical probability. So theoretical probability is based on the assumption that all outcomes are equally likely. And it is calculated as the ratio of the number of favorable outcomes to the total number of possible outcomes. Okay. For instance, the probability that you're going to get A, or the probability of a particular event or so, is actually number of favorable outcomes divided by, so it's ratio now, over total number of possible outcomes. So here it looks like number of, say, events all over number of sample space, something close to that. That's what this is about. So if we take this example, the probability, for instance, the probability of drawing a red card, from a standard deck. So the word standard is important because, it depends on, so some card may have some other kind of specifications, but the well-known card, so the probability of drawing a red card from a standard deck of 52 cards, is, so, red cards are half of the whole thing, right? So there are 26 red cards. That's the total number of favorable outcomes, because our focus is on red card. So there are 26 red cards out of a total of 52 cards. That is equal to 1 divided by 2. So the probability that when you draw a card, it is going to be red is 50-50, as they say. So it's 1 out of 2 possibilities. So that's the idea of theoretical probability. So it means you have equal likelihood of any of the outcomes. So let's talk about experimental probability, which is another type of probability. Experimental probability. So here you are dealing with empirical data, so to speak. So this is actually based on the actual results of an experiment. Based on the actual results of an experiment. Okay. So now this is no longer theoretical, it is based on your own experience. So it is based on experiment, so to speak. So it is calculated as the ratio of the number of times an event occurs to the total number of trials, to the total number of trials. So mathematically, we can express that as if the event we're interested in is A. So probability, the experimental probability that A is going to happen is actually the number of times event A occurs divided by total number of trials. Okay, that said, let's drive the point home with an example. So if a coin is flipped 100 times and lands on heads 47 times, okay, the experimental probability of heads is 47 over 100, which is 0.47. Okay. So normally this doesn't make sense, right? Because I mean, in the sense of theoretical probability, we know that we always assume that there's 50-50 chance of getting a head and a tail. So when you toss the coin, you are going to have a chance of 1 out of 2 for either head or tail. But in this case, now in this experiment, so you want to carry an experiment and you toss a coin for 100 times and you count the number of times head shows up, and you found that to be 47. So now it has been removed from the realm of theory to experiment, and then you can actually calculate a probability based on that. So that is why now the definition is a bit different. It's now total number of times the event you are interested in, that which is head in this case, out of the total number of trials, which is 100. And that's why the probability of getting a head based on your experiment is 0.47. So it's slightly less than 0.5, which is what you get in the case of theoretical probability. Okay, so let's talk about the third type of experiment, the third type of probability, that is, and that is called subjective probability. Subjective probability. Most times people just say things like, especially when they're discussing politics, in the Nigerian context now, I don't know if it happens in your country. So somebody will just be like, oh, 80% of all, they'll just call it a particular figure like that. Maybe that's not even subjective. We can say it's subjective, right? But sometimes it is actually exaggerated too. So, but the idea of subjective probability is that subjective probability, right, is based on personal judgment, personal judgment, and of course that is most times flawed. So, subjective probability is based on personal judgment or personal experience or intuition So your intuition will be correct. So interestingly, so when it comes to subjective probability, there's a probability that you are totally wrong, and there's probability that you are correct too, right? So subjective probability is based on personal judgment, experience, or intuition rather rather than on objective data. Rather than objective data. So both theoretical and experimental probability they are based on data, you know. The only thing is that the contexts are different. So theory is like, fixed, while experiment is dependent on probably whatever determines how many times head shows up or something. It may be your location, or I mean whatever, any other factor. But for subject probability, you just pick something out of your own experience and use that as probability, of which can actually give us a context. So based on personal judgment, experience, or intuition rather than an objective data, that is what subjective probability is about. It is often used when there is a lack of historical data. So if there's no data to fall back on, so when there's a lack of historical data, or when making predictions, about unique or uncertain events. Okay, so that's possible sometimes. So let's look at a possible example. All right. So a sports commentator might estimate a 70% chance that a particular team will win a match based on their knowledge of the team's performances, strategies, and conditions. Okay. I mean, interestingly too, these days I think football. Okay, well, we are talking about sports generally, right? But if you talk about football in particular, right, there's a lot of data out there, so you can see even commentators speaking with precision, like, oh, this country has met this country 20 times in the past, and out of the 20 times, country A has won 11 times, while country B won 7 times, and they drew this number of times. So you have all those accurate data these days, because there's a whole lot of record keeping. So this can apply in this context or any other context. So with this, we come to the end of Introduction to Probability. Thanks for staying up till this point. And if you're yet to subscribe, be sure to do that. And of course, hit the notification bell so you can always get alerted each time a new video is released. And you definitely want to comment, like, and share so that more and more people can be part of the learning going on here. Catch you in the next video. Bye.